Have you ever wondered how the internet knows where to send your requests when you type in a website address? Welcome to the fascinating world of domain name system, or DNS for short, a crucial cornerstone of the internet that we so heavily rely on. In its essence, DNS is like the phone book of the internet, a grand directory that translates human-friendly website names into computer-friendly IP addresses. Let's break it down. When you type in a website address, such as www.example.com, into your browser, your computer doesn't inherently understand what that means. Computers speak the language of numbers, and thus it needs the numerical IP address associated with that website to fetch the web page for you. This is where the DNS comes into play. When you hit enter after typing a website name, a DNS query is fired off into the vast expanse of the internet, seeking the unique IP address linked with your desired website. This query bounces from your local DNS server to other servers around the globe until it finds the right IP address. Once the IP address is found, it's sent back to your computer. Your computer then uses this IP address to find the website you're looking for. It's like you've asked the DNS, "Where can I find www.example.com?" And the DNS has responded, "You can find it at this specific IP address." The beauty of the DNS is its speed and efficiency. All of this happens in milliseconds, so quickly that you don't even notice it. It's a seamless process that ensures you can access any website you want, from anywhere in the world at any time. Think of the DNS as the internet switchboard operator, connecting you with the destination you seek. It works tirelessly behind the scenes, ensuring smooth communication between your device and the countless servers that make up the internet. So, when you type in a website address, it's the DNS that directs your internet connection to the right place. So how does this happen exactly? Well, the first step in the domain name system process is rather straightforward. It involves your web browser checking its own cache to see if it has a matching domain name and IP address. You might be wondering, what's a cache? Think of it as a memory bank, a place where your browser stores information it has previously used. It's like a quick reference guide for your browser to check before it starts a more in-depth search. Now, when you type a website's address into your browser, it starts by doing a quick sweep of its cache. It's looking to see if it already knows the IP address that matches the domain name you've just typed in. If it does find a match, it's like finding a shortcut. The browser can then use that IP address to take you straight to the website. It's a bit like having a stored phone number for a friend. You don't need to look it up each time you want to call them. It's already there, ready and waiting in your phone's memory. But here's the catch. The browser's cache isn't infinite. It can't store every possible domain name and IP address combination. So it only keeps a record of the recent addresses you've visited. This is why sometimes when you visit a website you've been to before, it loads quicker than the first time you visited. Your browser remembers the way. Also, it's important to note that these stored IP addresses in the cache aren't permanent. They have a lifespan, known as time to live, or TTL. Once the TTL expires, the browser removes the IP address from its cache. This ensures that the browser doesn't rely on out-of-date or possibly incorrect information. But what happens if the browser doesn't find a match in its cache? Let's find out. When there's no match in the cache, the browser goes on a journey to find the right IP address. So, what happens next? Our browser now queries a DNS recursive resolver, which is usually provided by the user's internet service provider, or ISP. Think of it as your personal assistant in the vast world of the internet, diligently working behind the scenes to help you find what you're looking for. When this DNS recursive resolver receives a query, its first task is to check its memory, or cache. If the resolver has the IP address you're looking for stored in its cache, it promptly returns it. Much like a librarian who knows exactly where the book you need is on the shelf, the resolver saves you precious time and effort, and you're quickly on your way to your desired website. But what happens if there's no match in the cache? Well, the DNS recursive resolver doesn't give up. It takes the next step in this intricate process, reaching out to the DNS root servers. The root servers are like the backbone of the internet's address book. They don't have all the information, but they know where to point the resolver to find it. Imagine you're in a foreign city, looking for a specific restaurant. You ask a local, who doesn't know the exact location, but can tell you which part of the city the restaurant is in. That's what the root servers do. They might not know the precise IP address, but they can point the resolver in the right direction. In this way, the resolver continues its journey, starting from its cache, moving on to the root servers, and beyond. Each step is vital in the process, each query bringing you closer to your destination. The beauty of the domain name system lies in this interconnected network, a symphony of queries and responses that work seamlessly together, guiding your browser through the vast expanse of the internet. Now, the request has reached the root servers. What's next? Well, stay tuned to find out as we delve deeper into the fascinating world of the DNS in our next segment. The root servers are like the traffic signals of the internet, directing requests where they need to go. Imagine you're driving through a city you've never visited before. Without traffic signals or signs, you'd be lost. The root servers function in much the same way, guiding your internet request to the right destination. To understand this better, let's take a step back. What are these root servers? They are a network of hundreds of servers distributed worldwide, each containing a list of the top-level domain, TLD servers. When a DNS resolver sends a request to a root server, the root server responds by pointing the resolver to the appropriate TLD server. Let's say you're trying to access a website with a .com domain. The root server will direct your request to a .com TLD server. These TLD servers are like the city maps, helping you navigate within a specific area. In our case, the area is the .com domain. Now, within the .com TLD, there are millions of domains. So how does the resolver know where to go next? This is where the authoritative name servers come into the picture. They are like the specific street addresses within the city. Each domain has an authoritative name server that holds the exact IP address for that domain. The TLD server directs the resolver to the authoritative name server for the specific domain you're trying to access. For example, if you're trying to access example.com, the .com, TLD server will direct the resolver to the authoritative name server for example.com, This authoritative name server holds the key information, the exact IP address for example.com, It's like finally finding the correct street and house number in our city analogy. So in a nutshell, the root servers direct the resolver to the TLD server, which further guides it to the authoritative name server for the specific domain. It's a well-orchestrated journey, ensuring that internet requests find their way to the right destination. Finally, the resolver has found the authoritative name server for the domain. What does it do with this information? Well, that's a tale for the next scene. Stay tuned. The authoritative name server is the final stop on this journey. It holds the IP address for the specific domain. This is where the magic happens, where the cyberspace equivalent of a treasure chest is unlocked. The authoritative name server, like a knowledgeable librarian, has the exact location of the website you're trying to reach. When the resolver asks for the IP address of the domain, the authoritative name server responds with a confident, "Yes, I have that information." It then hands over the IP address, like a key to a secret room, back to the resolver. The resolver, now armed with this precious piece of information, returns it to the browser. It's like a messenger returning with the exact coordinates of a hidden island. The browser, like a skilled captain, uses these coordinates to navigate the vast seas of the internet and connect to the server hosting the website. And voila! You've arrived at your digital destination. The web page you were searching for loads on your screen, all thanks to the intricate dance performed by the DNS. Now, let's take a step back and look at the bigger picture. The DNS, or Domain Name System, is like a sophisticated phone book for the internet. It translates the website names we humans find easy to remember into the IP addresses that machines use to identify each other on the network. The process starts with your browser asking the resolver for the IP address of a domain. The resolver then goes on a quest, consulting various name servers, the root, the TLD, and finally the authoritative name server, to find the IP address. And once it has it, the resolver gives it back to the browser, which can now connect to the website's server. So there you have it, the magic behind how your browser finds websites on the internet. The DNS working behind the scenes to make your internet experience seamless.